So, here we are again. Welcome back to yet another seemingly simple programming problem, made unnecessarily complicated by recursion. The method computer scientists adore, mostly because it makes them sound smarter than they actually are. Today's delightful torture is the art of reversing a string, recursively, of course. Why do it simply when you can waste CPU cycles and memory, right? String reversal is exactly what it says on the tin. You take a string and flip it backwards. Yes, like reading the ingredients list on your frozen pizza in reverse, only slightly less depressing. For example, turning the word chat into TAC or hello into hola. If you're impressed by that, then congratulations. It's officially time to raise your standards. Recursion, for those still blissfully unaware, is when a function calls itself repeatedly to break a problem down into smaller, more manageable chunks. Think of it like procrastination. Instead of solving the whole problem immediately, you keep passing smaller and smaller parts of it to your future self, hoping someone, probably still you, unfortunately, eventually handles it. For reversing a string, recursion tells us if your string is empty or just one character, it's already reversed. Well done, genius. Otherwise, reverse everything after the first character, then stick that lazy first character at the end. It sounds easy, mostly because it genuinely is, yet somehow we've managed to wrap it in enough theoretical fluff to make even the simplest things confusing. Python, being Python, loves to flaunt its simplicity, like that annoying friend who effortlessly aces exams without studying. Reversing a string recursively in Python looks suspiciously clean. If your string has one character, return it, because reversing a single letter would just be madness. Otherwise, recursively reverse the rest of the string minus the first letter, then smugly tack the first letter on the end. And then we come to C, a language that believes simplicity is overrated and direct memory manipulation builds character. In C, you can't simply slice a string. You must navigate it using pointers. Imagine being lost in IKEA, but instead of helpful signs, you have cryptic smug arrows pointing vaguely towards exit. Welcome to pointers in C. The Bash, a scripting language that really wasn't designed for this, tries anyway. Here you'll awkwardly cut strings apart and recursively glue them back together like some sort of desperate DIY show. It's as painful and inefficient as assembling furniture with duct tape, but it gets the job done, barely. Let's reverse chat recursively, because that's exactly how everyone wants to spend their day. First, you're not satisfied with chat, so you say, let's deal with hat first. Then hat feels overwhelming, so you defer to reversing at. That sounds too tricky, so you delay again to reversing just T. Finally, you realize a single letter is reversed already, well done, and then lazily start rebuilding T, then Tai, then Ta, and eventually Tak. Congratulations, you've wasted far more time than an iterative solution would have taken, but you sound smarter doing it, apparently. Every recursive call stacks onto memory, creating a delightful pile of deferred tasks your computer has to remember. Picture your to-do list getting progressively longer and more unbearable until you finally hit a breaking point and start frantically crossing things off, except here the crossing off is done automatically by your computer once it reaches the base case. Trust me, your computer secretly hates you right now. In languages like Python, recursion combined with string concatenation results in an efficiency that's frankly embarrassing, slowing things down to quadratic complexity. It's the computing equivalent of taking 2 steps forward and 1 step back, repeatedly until everyone gets bored and leaves the room. But does it matter for small strings? Of course not. You're never going to reverse War and Peace anyway, but pretend it's important. It makes you look diligent. An iterative solution, of course, is more efficient. It simply reverses the string without repeatedly torturing the call stack. There's no drama, no excitement, just plain boring effectiveness. It's like opting for water over champagne at a wedding. Smart but dull. String reversal is actually used in text processing, DNA sequencing, and cryptographic algorithms. Despite sounding like a party trick you'd never actually perform at a party. Understanding recursion here isn't about practicality, though. It's about learning how to make problems smaller until they're manageable or your head hurts sufficiently to stop caring. The recursive reversal teaches several crucial lessons. First, recognizing base cases, which is just a fancy way of saying knowing when to quit. Then there's decomposing problems into smaller, identical sub-problems, essentially delaying solving the actual problem. Next, understanding the implications of call stacks and memory, which is realizing your computer isn't limitless. And finally, evaluating algorithmic efficiency or pretending you care about performance. And crucially, it highlights how different languages handle the same task, some elegantly, others as gracefully as a drunken giraffe on roller skates. Recursive string reversal is beautiful in theory, mildly annoying in practice, and ridiculously inefficient in reality. But that's exactly why we study it. To understand how complexity can hide behind elegance, and also because making life complicated is a programmer's secret hobby. Now go forth, reverse your strings, impress no one, and quietly switch back to iterative solutions when performance matters. See you in the next unnecessarily complicated explanation.